Hello students, so in our topic of chemistry, that is atoms and molecules, we are on our next topic, and the next topic of our discussion will be the molecular formula of ionic compounds. Ionic compounds are those compounds which are formed when an atom gain or lose certain type of electrons. So now we will learn about the formula of ionic compounds, and I'm again repeating, for this you have to learn the electropositive and electronegative radical tables. So now we are on the formula for the ionic compounds. In the previous lecture, I have told you about certain steps which must be followed for writing the formula for molecular compound. So in this sequence, we have our next formula, that is hydrogen sulfide. So how will we write the formula for hydrogen sulfide? In our step number 1, we will write the symbol for both the compounds. For hydrogen, we have a symbol H, and for the sulfide, we have a symbol S. Now, we will write the corresponding valencies below them. In our step number 2, what we are actually doing, we are writing the valencies for this. For hydrogen, we have a valency of +1. Here I am showing +1 because we are studied about the formation of ionic compounds here. And for sulfide, we have a valency -2. Now, in the third step, what we are doing, we will crisscross the valencies. We will do crisscrossing of valencies. So here we are doing the crisscrossing of the valencies. We have considered H and S. We have its two valencies, +1 and -2 over here. Now I am going to crisscross these. This will be shifted in this subscript and +1 will be shifted in the subscript of sulfur. So in our step number 4, we will get the formula of a compound, but the formula will be written without a sign convention. So we will get H2 and S. So it is the formula for hydrogen sulfide here. So for hydrogen sulfide, we have a formula H2S. Now we will consider our second example. We have our second example, that is potassium and bromine, and the formula will form of a potassium bromide here. So again in our step number 1, what we are doing, we are writing the symbol for both the compounds. For potassium, we have a symbol K, and for the bromine, we have a symbol Br. Now we will write the corresponding valencies below them. In step number 2, we will write the corresponding valencies of that. We have potassium at +1 valency and we have a bromine at -1 valency. Now our step number 3, what we will do, we will crisscross these valencies. In our step number 3, we will do crisscross of these valencies. So we have +1 valency for potassium, and for bromine we have a -1 valency here. So for K we have +1 and for bromine it is -1. Now we will do the crisscrossing of valencies. This -1 will be shifted here and bromine +1 will be shifted here. So in our step number 4, we will get the formula of a compound, that is KBr. It means 1 and 1 having a common factor 1. So it has been solved and we will get the formula, that is KBr, which is a formula for potassium bromide. One thing it is important to remember, that I have explained you in our earlier class, that the most electronegative element will be kept in the right side and the least electronegative element will be kept on the left side. So this is a point of consideration here. Now we are writing about our third formula. Our third formula will be of ferrous sulfate. So again in our step number 1 we will write the symbol for both the compounds. In our step number 1, what we will write for the symbol of ferrous? Ferrous is an iron, so symbol here is Fe. And for sulfate we have a symbol SO4. Now what we will do here, in step number 2 we will write the valencies of the corresponding atoms here. In our step number 2 we will write the valency. For ferrous we have a valency of +2, and for sulfate we have a valency of -2. For writing these valencies, it must be reminded that we have to learn the tables for electropositive and electronegative elements separately. Now in our step number 2, what actually we are doing, we will do the crisscross of valencies again. Here we will crisscross the valencies. We have Fe and SO4 here. The valencies will going to crisscross here, and in our step number 4 we will get a molecular formula for that compound, that is FeSO4, because 2 will be cancelled by 2, having a common factor 2. So formula for ferrous sulfate will be FeSO4. So I hope these steps will be clear to you after learning about the electropositive and electronegative elements. Now we are discussing some more example so that this topic must be clear to you in every possible way. So for your convenience, I am writing some more formulas over here. So in our next category we have a formula number 4, that is aluminium phosphate. So what actually we are doing here, suppose we are containing a polyatomic ion instead of monoatomic ion. So what we will do, we will enclose the polyatomic ion in a bracket, so it may be convenient to write the molecular formula. So here I am showing you how we write the formula for the polyatomic ions. So in our step number 1, again we are writing the symbols for the compounds. For aluminium we have symbol Al, and for the phosphate we have a symbol PO4. Now in our step number 2, what we are doing, we will write the valency of the corresponding elements below them. For aluminium we have a valency of +3, and for phosphate we have a valency of -3. Now in our step number 3, again we will do the crisscrossing of valencies here. In step number 3, what we will do, we will write Al over here, PO4 here, +4 +3 -3. Now crisscrossing of the valencies will occur, and in our step number 4 we will get the formula for the compound. Al3 PO4 3. As I have told you earlier that P and O4 is a polyatomic ion, it means it is made up of more than one kind of element, so I enclosed this in the brackets. Now here we have +3 and 3 here is a common factor, so we will divide the entire formula by 3 and we will get the final formula, that is AlPO4. This will be the formula for aluminium phosphate. Now proceeding to our second formula, that is we will talk about sodium bicarbonate. Sodium bicarbonate is also known as sodium hydrogen carbonate. Its another name is, we may call it as sodium hydrogen carbonate. Now we will again repeat the steps. For sodium, in step number 1, for sodium we have a symbol Na, and bicarbonate is actually the hydrogen carbonate. So for the symbol of hydrogen carbonate we have HCO3. Now what we will do, we will write the corresponding valencies below them. In our step number 2, we will write the valencies. For Na we have a valency of +1, and for sodium hydrogen carbonate we have a valency of -1. In step number 3, we will again do the crisscrossing of valencies here. So it can be written as NaHCO3. +1 and -1 will be cancelled out because these are the common terms. So formula for sodium hydrogen carbonate will be NaHCO3. Now moving to our next formula, that is potassium dichromate. So again in the step number 1 we will write the symbol for that elements. For potassium we have a symbol K, and for dichromate we have a single symbol Cr2O7. That is, it is a combination of chromium and oxygen. Now in step number 2, what we will do, we will write the corresponding valencies below them. I'm again repeating, the most electronegative element will be put on the right side and the less electronegative element will be put in left side. So potassium we have a symbol +1, and for dichromate we have a symbol, we have a valency of -2. Now again in step number 3, what we will do, we will crisscross these valencies. It means this valency will be shifted in its subscript and this will be shifted over here. So we will write K2 Cr2O7 and 1 will be shifted over here. So finally we will get the molecular formula of a compound, that is K2 Cr2O7, and this is actually the potassium dichromate. So students, here I have discussed almost 6 formulas or 6 ionic compound formulas, and we have many more formulas in this series which can be explained or which can be written in a similar way. If someone want to note down it, please note down it. So this lecture is over for today. In our next class we will discuss about many more terms, that what actually the mole concept is, what is Avogadro's law, and learn about the Dalton's atomic theory. Thank you so much and have a nice day.